Our lesson is chapter 5, state of matter. So this is cover the 5 hour. So our lesson today, we are focused only the concept of the gases. So the concept of the gases we can consider for here, it have the basic assumptions of the gas, but we need to use the kinetic molecular theory, and we have the gas law, either Boyce, Charles and Avogadro. So next we need to compare the graph between Boyce and Charles law, perform the calculation by using the ideal gas equation, find out the molar mass, and finalize we need to discuss about the Dalton's law. But for today we are just cover only the 3 gas law first here. So we go through the basic properties of the gases, which is we can call as a general properties. So basically the gas has a lot of space compared to the solid or liquid, because if we refer to the arrangement of the particle in gas, okay, the gas is very small, so the arrangement particles are far each other. So this is why we are state they have the more space between them. So the density of the gas is much lower compared to the solid and liquid, and other than that, this gas also can be expanded and follow their volume in the shape of container. So at the same time also the gas is easier to the compressible compared to solid and liquid, flow readily, and they are easily to mix. So we have the 24 liter and 22.4 liter. So this is we can call as the molar volume. So these values are occupied at 1 mole of the gases. So according to the kinetic molecular theory, so it's used to describe the ideal gas. So this kinetic molecular theory must be obey according to the ideal gas, that it must be obey the equation PV equal nRT. So this kinetic molecular theory must be explain the behavior of the gas. So we have the 5 postulate of kinetic molecular theory. First thing, the gas particles are very small, and the particles of the gas are moved randomly, and they are in the constant. So during they are moved randomly, the collision between the particles are perfectly elastic, and the volume of the gas are negligible. So it's assumed the volume of the container. So the intermolecular forces or the attraction forces and repulsion forces are negligible. Therefore, the finalized here, the kinetic energy of the molecule is directly proportional to the absolute temperature. So we can summarize the kinetic molecular theory of the gas by using this simplification, and we can clarify as a V's. So V is belong to the volume of the gas are negligible, so it's use the volume of the container. Intermolecular forces between the gaseous particles are negligible. The collision of the particles are elastic. The temperature of the gas is directly proportional to the average kinetic energy. Means the higher the temperature, so the higher the kinetic energy, and the S here belong to the small of the particles, which is it can move in the straight line in the random motion. So we discuss the summarize according to the kinetic molecular theory based on to the diagram. So if we have the arrangement of the particle kinetic molecular theory, so we are focused on the first thing. Particles are very small and they are arranged in a randomly. At the same time, these particles are moved in the straight line motion. So I state that this is your S symbol, which is as a small particle and move randomly. So during the particle are moved, the particle will collide to the wall container, and during the particle collide to the wall container here, at the same time, it also collide to each other with another particle. So this collision we can call as a elastic collision. Okay, so I state for the E symbol, And at the same time, you notice that the arranged particles are far each other. So, we can find out intermolecular forces are neglected. So, we know the volume of the gas here are neglected. So, what happened? The volume of the gas is equal to the volume of container. So what happened here, if I have, when I apply ataupun when I hit the container, the kinetic energy of the particle is directly proportional of the temperature. Means the higher the temperature, the higher the kinetic energy. So we summarize for the kinetic molecular theory. So we can come out as E, T, V and I. So when you combine together, V, I, T, C, S, VITS. Okay. So you must be remember lah the concept of kinetic molecular theory. So we proceed to our next lesson. Exercises, I hope you feel it. So we focus on to the first law. So we have the several law for here, which is a 5, but for our lesson only 3 here. So Boyce, Charles and Avogadro. So we discuss for the first year, but you must be remember for this conversion unit. So for this chapter, we use the conversion unit especially for the part for pressure. So the unit for pressure, we have writing the several unit, either ATM, mmHg, torr, Pascal or Newton meter. So the familiar units or basic unit is 1 ATM. We just documentary lah to find out the differences of the unit for the gas pressure. So according to the Boyle's law, the variable in Boyle's law, which is the volume and pressure, you can call the volume of the gas at the fixed amounts of the gas, which is the value of N is constant, and fixed of the temperature. So it is inversely to the pressure of the gas. Means when the volume container increases, so the pressure of the gas will decreases. The smaller size of the container, the higher the pressure of the gas. So we can come out for this diagram, and also when we have the two situation, means okay, the first situation, our first situation we can have, okay, the volume of the container is 2 liter, and then the particle of the gas collide to the container to produce a pressure. So the pressure for here is 1 atm. When I compress the container, so the second situation can be produced, the smaller area of the container, so the volume of the gas will decreases, so which is 1 liter, and therefore we can find out the pressure of the gas is higher than for the first. So for example, the pressure of the gas is 2 atm. So this is the comparison, this is the graph, the pressure versus of volume. So this, the first graph is inversely proportional. If we have the straight line graph, so the pressure is directly proportional to the 1 over volume. So when we have the two conditions finalized, we can find out the specific formula is P1 V1 equal to P2 V2. So this formula we always use to calculate in the calculation step. So we try according to the first and second example, but for lesson for today, I show you for the first example. For the example 1, we have the chlorine gas occupy the volume of the gas 2 liter. The pressure is 1. Okay, so the example 1, we have the volume of the gas at the pressure 1 atm. Calculate the new pressure if the volume of the gas increases to 5 liter at a constant temperature. So we calculate it together. So we have the first container. In the volume of the gas is 3.2 liter. Oh, sorry. So for example 1, we have the container and occupy the gas. The volume of the gas is 2 liter. The pressure of the gas is 1 atm. So the volume container is increases into the 5 liter. So the new volume is the 5 liter. So find out the new pressure. So means that this is your first situation and this is your second situation. So by using the relationship formula P1 V1 equal to P2 V2, we just substitute the value pressure 1 atm times your volume 2 liter. Our new pressure is our target and the volume of the gas is 5 liter. So finalize, we can get the new pressure is 0.4 atm, and we can conclude that the greater the volume of the container, the lower the pressure of the gas. For the example 2, I want you to do it by your own self. I proceed for the second law, the Charles law, the variable in Charles law is the volume and also the temperature. So means the volume of the gas is directly proportional to the temperature of the gas at the fixed amounts of the gas and at the constant pressure. But this temperature must be in unit Kelvin. So in unit Kelvin, we know that 0 degrees Celsius must be equivalent to 273.15 Kelvin. So this just also when we increase the temperature of the system, so therefore the container also expanded, so the volume of the gas also increases. So the situation we have two situations and we combine the situation together, finalize. This is our directly formula when we want to calculate the data, which is B1 over T1 equal to B2 over T2. So this is the graph of the Charles law, and we try to example 1 first. So when we have the volume of the container 3.2 liter and temperature is 1 to 5 degrees Celsius and the sample is cool, so means we lower the temperature here, but the volume of here also lower because this is considered the charge. Volume is directly proportional to the temperature. So we try it together by. Okay, so the first example, for the example 1 here, when we have the container, this is a particle of the gas, the volume of the container is 3.2 liter, the temperature is 1 to 5 degrees Celsius, and then the situation is cool, means we reduce the temperature of the system. So we can provide the new volume of the gas is 1.54 liter, and we need to calculate the final temperature in degrees Celsius. So what should you do? So you know that if the temperature, if the volume, the container is the lower, the temperature must be lower. So by using the formula V1 over T1 equal to V2 over T2, so your temperature must be in Kelvin when you substitute the data. So 3.2 liter over 1 to 5 plus 273.15 Kelvin. Okay, this is the unit of Kelvin, equal to the second situation 1.54 liter. So this is your new temperature. So our new temperature here must be in unit Kelvin. So for example, I give you X unknown. So how you find out the temperature in degrees Celsius? So conclusion, our value of the temperature must be, if we have the X value in Kelvin, so it's equal to the T2 plus 273.15 Kelvin. So finalize T2 you can get in unit degree Celsius, because we have the constant here, 0 degrees Celsius must be equivalent to 273.15 Kelvin. So for the example 2, I want you to try based on your own self, and this is your task for example 2. So we combine the gas between the Boyce and Charge law, and we substitute the equation together. Finalize, this is our final equation we use in data calculation. So we try by using the exercises question based on to the example number 1. So example number 1, we have the methane gas with the volume of the gas 25.5 liter. The temperature already converted in Kelvin and the pressure in Pascal. Calculate the volume at STP. So we try it together. According to the concept of the combination, okay, we have our first situation. This is our gas, okay, and this gas consists of volume which is 25.5 liter. The pressure is 153.3 kilopascal and the temperature is 298.15 Kelvin. So therefore we have this new situation. Find for the second volume, but let us state that this is at STP. So you know that at STP, temperature must be 0 degrees Celsius, the pressure is 1 atm. So therefore, this is the combination between Boyce and Charles law by using the formula P1 V1 equal to P2 V2 over T, right? So what should you do? You must be convert your first data here, okay, by using the similar unit. So this must be converted into Kelvin, and this you must be converted into atm. So we convert the pressure in atm first. So the pressure for atm P1, so you know that 101.325 Pascal is equivalent to 1 atm. So if you have 153.3 kilopascal, so we can get the data. So 153.3 times 10 to the power of 3 Pascal times 1 atm over 101.325 Pascal. Today, as your task to analyze your information in Boyce law. Example number 2, Charge law. Example number 2, Charge law, and also each example number 2 for each cases law. So you pass up into our GC, right, for today before 12. Okay, done. Thank you.